Ms. Russ went to study on her own.
Exactly. Build my own self. Anyways, so today we're going to be doing 7.2, which is going to be modeling exponential functions. So just a reminder that 7.1 is due tonight. Alright, so some key concepts and main ideas. The most simple form for this is going to be y equals a times b to the x, and that models growth and decay. We'll look at some more versions of that formula today as well. A represents the starting value, so how much you start with, a population that you start with, the amount of money you start with, etc. B represents the base. This is either a growth factor or a decay factor, it's one or the other. And then the x is just the exponent, usually in time, so years or whatever, months, whatever we're dealing with. And then we have to know the difference between rates and factors. So this is really, really important and essential for this lesson, knowing the difference between the two. A growth or decay rate is like a percentage. So like 15% growth, 15% decay. A growth or decay factor is when you either add one or do one minus that rate. Okay? And we'll talk about when you add and when you subtract and how to determine that. So the first thing we're going to do is we're going to convert these growth and decay rates into growth and decay factors. So they're going to have to tell you if it's a growth or decay rate, but if they don't mention it at all and they just give you a percent, you assume if it's positive that it's growth. So first thing you have to do is you're going to convert this growth rate into a decimal. So what is 25% as a decimal? 0.25. So if you're wondering how to do it, you move the decimal place 2 places to the left. Do you remember this from whenever you learned it?
Yeah.
Okay. So now what you do is we determine that it's growth. So growth, to find your growth factor, you do 1 plus whatever that rate is as a decimal. And that comes out to be 1.25. And this is called your growth factor, and this is what you use in the formula. Now importantly, you need to know how to recognize a growth factor, and a growth factor will always be greater than 1 in a formula. Okay? Alright, so let's go ahead and identify a decay factor. So as you can see, this is decay because it is subtraction. So how could I convert this into a decimal? Very good. Negative 0.05. Don't forget, it's not 0.5 because 0.5 would have been 50%, right? So make sure you put that extra 0 there. So this is a decay factor. And since it's decay, you're going to do 1 minus that amount, which comes out to be 0.95%. I mean 0.95, not percent. 95% or 0.95. So decay factors will always be less than 1. That's because if something is decaying away, if you multiply it by that number over and over again, it's going to get smaller and smaller. And lastly, we're looking at this one. Which is it, growth or decay?
Decay.
Good. What is it as a decimal?
0.05.
Good. So what is my decay rate going to be here? Good, 0.98. So does anyone have any questions about identifying growth and decay factors?
No.
Okay. So now we're going to use this to do some real world problems, this concept. So I'm going to zoom in on number 1 here. It says a virus population of 10 doubles every minute. Okay. So we use the formula y equals a times, it's loading very slowly, b to the x, where a represents how much you started with and b represents your growth or decay factor. So if a population is doubling every minute, is that growth or decay?
Growth.
Good. So it's going to be y equals the initial population, which is 10, times your growth factor to the x. In this case, they gave us our growth factor right here. It's 2. So if they give you the growth factor, you don't have to do any conversions or anything. They've already given it to us. So anytime you're doubling, it's going to be 2, tripling is going to be 3, and so on. And then halving would be 1/2, which is 0.5. So any questions about that? And then what you plug in is minutes, so if you, after 15 minutes, plug that in, see how many are left. Alright. The value of a car depreciates 20% each year. Depreciation, is that growth or decay?
Sounds like decay. Decay.
It is because it's going down. So we have to convert this into a
Decimal.
decimal. What's it going to be?
0.2.
0.2. But we have to convert it now into a growth or decay factor. How would we do that?
G.
Good. Everybody know why it's subtraction here instead of addition?
Yeah.
So this is my factor. Any questions about the factor? So the formula is y equals the amount that the car originally was times your decay factor to the power of x or t. You choose what letter you want to use. Yeah. Good question. So if you see on the first page, see how when we have a decay, we have to subtract from 1? That's why we did that. So 1 minus 0.2 is 0.8. Okay. Any questions about that? So remember, you got to convert rates into factors. So the good news is somebody figured out that you're converting a lot of rates into factors, so they expanded the formula and they made a formula that builds that process into it. Okay? See how they converted b into 1 plus or minus r? So that represents the process of adding or subtracting from 1, right, built into the formula. Now this is one of these formulas that's really iconic in the math, financial, all those types of worlds. Okay? You'll see versions, if you Google exponential growth or decay rate, you're going to see hundreds of different versions of this formula. Okay? It really comes in about in so many different types of math and science. All right? So we're going to learn how to use it. So A represents your starting amount. 1 is going to help you find that growth or decay factor given your rate. Okay? So we're basically doing the same thing. It's not any different. It just builds it into the formula for you. So now we're going to look at population. The world population in 2020 was approximately 7.79 billion. The annual rate of increase was about 1.05%. Assume the rate of increase continues. What will the approximate population be in 2040 to the nearest 10 billion? So first thing we need to do is we need to identify what the initial population was. We're going to call that little a. So what's the initial population here?
7.79 billion.
Good. 7.79. We're going to leave off the billion and add it at the end. Now, the formula also wants R, which is your rate. So what is our rate here?
1.05.
Good. This is the rate as a percent, but we need to convert it to a. So we need to move the decimal place 2 places to the left. So it's going to be 0.0105. It's kind of weird when it's already a decimal in the percent, but that's how you do it. So now we're ready to use our formula. We have A and we have little a and we have R. So that's going to be A of t is equal to your little a times 1 plus or minus your rate to the power of t. But we don't need to do plus and minus. We need to determine if it's plus or minus. Good. Why is it plus here instead of minus?
Because you're trying to see the growth.
Good. It says the word increase, right? So that's what you have to do. You have to look at the context of the question and determine if you're adding or subtracting. Does that make sense to everyone? Well, we got one step left. But yeah, this is what the lesson is. Yeah, it's not too bad. So what are we plugging in for t here to figure out what the new population in 2040 is? 20. Everybody understand where the 20 comes from?
And the difference from the years.
Good.
Oh, okay.
So from 2020 to 2040, how many years have passed? 20, right? So now, here's the thing that I see the number one most mistakes with, so pay very careful attention here. When you put this in the calculator, you do this step first. You do this amount to the 20th power before you multiply by the 7.79. Because of order of operations, right? PEMDAS, exponent comes before multiplication. So does everybody have one of these handy calculators? Or you have one of the blue ones, whatever you have. Okay, so if you have one of these, here's how you do it. you're going to type in 1.0105, the base. You see that little button underneath the off button that has y to the x on it? You're going to hit that button, and then you're going to type in the exponent you want, which is 20, and you're going to hit the equal sign. You get 1.23 something. Now multiply that by the outside number, 7.79. And you get? Good. 9.6 because they asked me to round to the nearest tenth. And then what's the units on this? Billion. So if things go at this rate, we're going to have 9.6 billion people on Earth in 2040. It is a lot. Gonna overflow. Anybody have any questions about this so far? Alright. So now we're gonna do a money problem. You invest $500 in a savings account at a regional bank that pays 3.5% annual interest. How much will be in the account after 5 years? So I do want to mention that there are way more complex versions of this problem that can be asked with more complex formulas, but we're keeping it really simple today with annual basic interest, okay? But there are other versions of this that we'll get into. So, the initial amount of money you start with is?
500.
Good. And what is the rate as a decimal?
0.035.
Good, 0.035. Move the decimal place twice. And is it growth or decay? Growth. So if you're investing money and you're accruing annual interest, if you're accruing interest, that means that your account is going up. Now you wouldn't invest and make it and then keep your money in an account that was taking 3.5% of your money, right? So think logically through that. So that's going to be A of t is equal to the initial amount times, is it going to be 1 plus or 1 minus? To the power of t. And then what are we going to be plugging in for t? Good. So here's the thing that can be trip people up on this. We talked about annual interest. What does annual mean?
Yearly.
Good. So it's okay to plug years in there, right? But what if the question, instead of giving me years, gave me months? I would have to convert it to years to plug it into the formula, right?
So you would like times it by 12?
Yeah, so or divide it by 12 rather, right? So just be careful about that. There is one question on the homework where you have to convert the time into, it's an easy conversion, but so you do the math. 1.035 to the power of 5 times 500, and that means you end up with
593.8.
good. And why do we round money with hundreds place?
Because of the cents as 2.
Good, that's how we do cents. So here's the thing also I want to mention. I want to look back to this question about car depreciation real quick. Let's talk about why it's 0.8. So if your car is losing 20% of its value, that means it maintains what percent of its value? 80. So that's why we do 1 minus it, to talk about how much amount your car has left in it. Does that make more sense?
Yeah.
Okay. Additionally, if you all can do me a favor and look at 1, 2, and 3 on your homework. So you're working